Hi, I am Marco Lisi. I work for the European Space Agency. I was a former special advisor of the European Commission on space policies, and I'm presently advising the European GNSS agency, GSA, in Prague. I am going to give you a presentation about what I call the worldwide integrated PNT infrastructure, PNT being for positioning, navigation and timing. I will in fact try to have a look into the future of the area of positioning, navigation and timing. In summary, I will start speaking about the global navigation satellite systems. Everybody knows GPS and probably also the European program Galileo. These are systems based on constellation of satellites, and they provide the navigation and precise time to users all around the world. These systems, GPS, GLONASS, the Russian GLONASS, there is a Chinese one, Beidou, and the European one, Galileo, they all suffer from some limitations, similar limitations. First of all, their signals, the radio signals they broadcast are rather weak, and this doesn't allow, for instance, applications indoor or underground or underwater. So, just to make an example, these systems cannot be used to support mining, or in all cases where you do not have full visibility and good visibility to satellites in space. On top of that, they are also vulnerable and exposed to many possible type of attacks, and I will review some of them. Some type of attacks can be really related to their nature, that is based on computers and communications, so they are cyber type of attacks, but then specific to these systems are attacks based on jamming and spoofing. On the other hand, our society is so much based on these infrastructures that we need to guarantee a very reliable and continuous and resilient, so resistant to disaster, positioning, navigation and timing service. And what is the answer to this problem? Probably the answer is in using together different types of technologies, not only those based on GNSS, but also based on non-GNSS type of infrastructures and to autonomous type of platforms. Through this more reliable and continuous service in the future, there will be a closer integration with other areas of application, in particular telecommunication and Earth observation. So we can expect in the future this big infrastructure of our society, the telecommunication infrastructure, the Earth observation infrastructure, and navigation, positioning and timing infrastructure to be more and more integrated together. So let's remind ourselves about in particular the pillars of the European positioning, navigation and timing infrastructure, EGNOS and Galileo. EGNOS being a satellite-based augmentation system. Here we see its architecture. I do not want to spend too much time on EGNOS in itself, but this picture makes us understand why these systems are exposed to cyber attacks, for instance. As you can see, EGNOS and the architecture of Galileo is similar. It's very much an ICT type of infrastructure, information and communication technology infrastructure. Why? Because there are a number of stations and centers spread over a large territory, and they are all connected through communication lines. And in the centers, in the stations, there are a lot of computer-based technologies, a lot of processing, computer processing. So, and they are the network that is connecting this center can be exposed to digital type of cyber type of attacks. So it's evident that this type of architectures are weak in terms of their exposure to cyber attacks. And the Galileo architecture is similar somehow. Galileo is an independent system, So it has got an independent constellation of satellites, similar to the GPS one, but also Galileo relies on a very heavy ground infrastructure. In fact, the ground segment of Galileo is much more complex than the EGNOS one, and even in this case we have many centers, many stations, a huge data communication network that is connecting all the centers spread all over the world. So once again, this type of architectures make these systems very exposed to digital type of attacks. So the threats and vulnerabilities that can menace the performance of global navigation satellite systems are cyber attacks. In some cases, people even speak about real cyber war, jamming and spoofing, and then I would add one fourth area of concern, that is the weakness of the organization that are supporting this type of systems. So let's go through the different areas of threats and vulnerabilities. We remember very well, unfortunately, what happened in 2001, on the 11th September 2001, and many people fear that in the future there might be some other big terrorist act, but this time it could be based on digital type of technologies, so there could be really a sort of cyber terrorism in the future. So we have to get prepared. Unfortunately, there is an escalation of this type of attacks. In the United States, more than 200 cyber attacks were reported in 2012, all against the critical infrastructure. I'm not speaking here about cyber attacks of the type those are thousands, hundreds of thousands, or even millions that in terms of viruses or malware, those are very diffused, and everybody is subject to this type of attacks. Here we are speaking about attacks to critical infrastructure, so infrastructure that are essential for the survival of our society. So the number reported here is very important. These are organized attacks, and in some cases the US government says that these attacks could be reported, somehow linked to foreign countries or foreign type of military or government institutions. The areas where the attacks were performed are different, but they were attacking infrastructures in energy, for instance, the electric power distribution system or the water distribution systems, all the main infrastructure that support the everyday life of our society. And why are critical infrastructures so vulnerable? Because they are interdependent. The electric power distribution system is linked to many other types of infrastructure, for instance, the water distribution system, or it is supporting many other areas like the transportation infrastructure, or even commercial type of infrastructures like banking and finance. So whenever you attack one of these infrastructures, you create a sort of domino effect, and you disrupt very heavily the good performance of our society. GNSS, navigation, positioning and timing, is supporting all infrastructures in a way that sometimes we underestimate. It is essential for many infrastructure of our society to be able to control the position, but also timing is more and more essential in many applications. The precise timing is essential for the electric power distribution network. It is essential in many commercial type of applications, starting with the banking and finance. And so it's evident that to attack GNSS is unfortunately effective way to disrupt the performance, the good functioning of our society. In terms of jamming, another area where the GNSS can be somehow under attack. Here you see very heavy jammers. Jammers are transmitters, very high-power transmitters that are transmitting signals that are much higher in power than the GPS or Galileo signals. So when you have jammers in an area, in fact, all users cannot receive the GNSS signals. In this picture, you see very powerful jammers that can reach powers of up to megawatts. And in particular, this picture refers to North Korean capabilities that were able some years ago to wipe out completely the GPS signals in all the Korean peninsula, and in particular in South Korea. But you do not need to go for megawatts type of jammers. There are many commercial available GNSS, in particular GPS jammers, that you can buy even online. And they are available in different sizes and different prices, starting from the simplest one for a few tens of dollars. You can buy a jammer, and you would ask yourself why people buy jammers online, commercial jammers of GPS. And the reasons are very different. In many cases, husbands and wives use these jammers to be sure that nobody can locate their position, their movements around, for whichever reasons, they know why. And the result is that there is a big pollution of the GNSS frequencies in the world. One very cheap jammer that you buy for a few dollars is able to disrupt the performance of GPS or other GNSS systems in a very wide area. Even a small jammer with a few milliwatts of power can in fact very heavily affect the performance over an area maybe of 1 kilometer or more in radius. So this is other threats that are undermining the performance of GNSS infrastructures. Spoofing is more sophisticated. With spoofing, you do not try to wipe out the GNSS signals, but you try to confuse the users. So you create some fake GNSS signals, making the user think that he is in a different position from where he is, and you make him go to a different destination. In the past, people thought that this technology was very sophisticated, and so it was requiring big capabilities in terms of money, in terms of know-how. But recently, some students from University of Texas, they have shown that with a very small investment of a few $1,000s, with equipment that was commercially available, they were able to spoof the navigation of a yacht. Of course, this was organized, it was an experiment, and the captain of the yacht got completely confused, and its track was changed without him knowing, because the navigation system was relying on GNSS, and they were assuming the signals received were right, when instead they were completely spoofed, they were fake ones. So this shows that even in this respect, GNSS are not 100% reliable. They can be attacked, they can be somehow affected by intentional or unintentional type of problems. Then there is also what I call an organizational weakness. In April this year, in 2014, something very unusual happened. GLONASS, that is the second global navigation system having been developed in the world after GPS, and that is also fully operational, and it is present nowadays in many smartphones. So we might not know, but in many of our smartphones, the chips, the navigation chips, are compatible with GPS and GLONASS. In April, I was saying something unexpected happened. For 12 hours, GLONASS went down. In fact, it was broadcasting completely wrong navigation messages, and users got errors huge in terms of tens of kilometers. So it was no longer possible to use the GLONASS satellites. And a few days later, the problem occurred again for a shorter time, And so far, nobody has completely understood, maybe the reasons are known, but they are not disclosed, what really happened. Personally, I think that this shows that the technology is not enough. GLONASS is a well-conceived signal. It was operational for many years, so surely the problem could have been a technical problem, but it cannot be that a system so complex and so important can go down for many hours for some technical problems. The organization that is around the system, supporting the system, must be able to compensate for this type of problems. And in that particular case, the reaction was very slow. For 12 hours, it was not possible to use the system. So people are worried around the world because at the moment we rely very much on GPS and GLONASS. In the future we'll have other systems such as Galileo. But many people think, are we sitting on a time bomb? This is really the expression that is used. Is GNSS a time bomb? Are we relying too much on this type of systems, not thinking that in the future, if something happens, suppose that in April, together with GLONASS, even GPS had experienced some other problem because of an intentional or unintentional attack or whatever. What was going to be the situation in the world? What was going to happen to all the infrastructures of our society that are so heavily based on GNSS? So people are worried, and they think that maybe we are mistaken in relying too much on GNSS. I personally think that GNSS are going to be also in the future very important, and we cannot get rid of them. But we have to find ways to alleviate and mitigate the problems that can affect these systems. So it doesn't need to be a time bomb. GNSS do not need to be a time bomb. We can find solutions to them. I think that there are 4 ways to improve the performance, let's say, our reliance on a resilient PNT infrastructure. The first is to get a higher interoperability among the present GNSS infrastructure systems, then to improve and develop service-oriented type of organization supporting these systems, but also to develop in parallel non-GNSS based navigation, positioning and timing systems, and to also develop autonomous platforms able to make a fusion of different type of sensors. Let's go through the 4 areas of improvement. So today we are already, we mentioned it, in a multi-constellation scenario. GLONASS and GPS are fully operational, but also the Chinese system is catching up, and it is operational at least over the Asian continent. And Galileo will get soon to full operability. So we are already in a multi-constellation scenario, and this somehow alleviates the problem that can derive from hiccups related to one specific GNSS. The same is for satellite-based augmentation systems. EGNOS is operational in Europe, but it might extend its capabilities to the African continent, but there are similar type of augmentation systems in the rest of the world, in the different continental regions, and we have to expect that in the future more and more these systems will be interoperable to guarantee that their services in a seamless way to users, for instance, traveling from London to Moscow. It's unthinkable that an airplane that is using EGNOS in Europe, flying over Russia, cannot guarantee the continuity of its navigation support. So interoperability has to happen more and more, both for global navigation satellite systems and for satellite-based augmentation systems. So we have to go for what I call a GNSS system of systems. And I mention here the 4 major players that are GLONASS, GPS, Galileo and Beidou, but in the future there might be other ones. For instance, there is a Japanese regional satellite-based system that is already operational. So this is going to be a guarantee that somehow each system is interoperable with the others, and that we can count on a better reliability of the overall system of systems. But we also have to move, let's say, to get stronger the organization that is supporting these systems. In the specific case of Galileo, we have to go from products to a system, but then also to a service system. So the products are the components of specifically the Galileo system, the satellites, the centers, the monitoring station. All together with the proper architecture behind and the proper design, they become what Galileo is going to be, a system that is providing good, very good and state-of-the-art performance. But it's not enough to have a good technological system. We need to support it with some other facilities and organization that guarantees really the service to the final users. So specifically for Galileo, we are developing service centers that will interface users and will also get queries and problems from users. We have set the European GNSS agency, GSA, in Prague, that will be really the agency supporting the service organization of Galileo. We have developed an infrastructure to take care of the security of Galileo, once again because we need to protect the system being such an important infrastructure for Europe and the rest of the world. And also we have to engineer really the services. It's not enough to engineer the system from the technical and technological point of view, but also we have to engineer the organization that is, through the system, providing services to users. So this is a way to improve the reliability and continuity of the service or type of organization. And the example in this slide is that of the Galileo Service Center in Madrid, that was inaugurated last year. And the center provides, among other things, a website that is not just one more website about Galileo. It is important to notice that it provides a help desk, so it is creates a direct link with users and service providers to get questions and to reply to these questions, technical and operational type of questions, and also inform the users and the service providers about the actual status of the system, giving them updated and reliable information about the status of the constellation of satellites in orbit and the overall status of the system. And I would invite you to go to this link shown in the slide and see what the Galileo Service Center website looks like. I mentioned before the problems created by North Korea through their very powerful jammers in the Korean peninsula. And the way that was adopted by South Korea to counteract this problem was to develop their own non-GNSS based system. It was a system revitalizing an old navigation system, LORAN. The present name of the updated approach is called E-LORAN. And they have established, it is completely ground-based, so it doesn't need satellites in orbit, and of course can rely on much higher radio signals because the sources are all on ground. So they have equipped their territory with a number of stations, and this E-LORAN, South Korean E-LORAN, is able to make them completely independent from GPS. Of course, they keep using GPS and they keep using in the future also other systems, but in case of problems with GNSS, they have a non-GNSS, completely independent type of infrastructure. Of course, it is only regional. So this is another way to compensate for the problems of GNSS systems and to integrate them with non-GNSS ground-based capabilities. There are other ground-based ideas already operational, for instance, in our smartphones, using the so-called signals of opportunity. They can be Wi-Fi sources. In this case, in this picture, you see the use of digital TV broadcasting stations to be able to derive your own position, your position on ground. And these type of applications are getting more and more spread, and they are also integrated into our smartphones. So this is another approach, again, to get your position, maybe with somehow lower accuracy, but in a way independent from GNSS. It's obvious that I'm not saying that the GNSS are no longer needed. They are needed, especially because they provide very high accuracies and everywhere in the world. But wherever possible, we should integrate with non-GNSS type of infrastructures. And then there is another area that has been recently developed, that is that of platforms that are completely autonomous and independent from external sources. They are actually based on inertial sensors that are able to sense your movement and your acceleration, and on atomic clocks. The point is that recently this type of device have been miniaturized, and this was a development sponsored initially by the Defense Research Agency in the United States, but now some of these components start getting commercially available, and you see that you can get inertial platforms and atomic clocks so small that very soon they'll be integrated into our smartphones. So what I expect in the near future is that in our personal devices like smartphones or car receivers, we'll have, together with chips able to receive GPS, GLONASS, Galileo, we'll have other ways to determine your position and timing based on other type of sources, non-satellite based, but also on inertial platforms and atomic clocks. So my personal vision for the future is that of a PNT system of system infrastructure that will be out of the fusion of three areas. One that is the original and GNSS system of systems that will remain being the cornerstone of this PNT worldwide infrastructure, but also integrated with the non-GNSS type of systems, those based on E-LORAN or Wi-Fi sources, other signal opportunities, even the GSM network itself. And the third, by the area of autonomous PNT platforms based on inertial sensors, miniaturized inertial sensor and miniaturized atomic clocks. This is going to be a much more reliable and resilient type of infrastructure, and the technology is there, and we are in fact already using some of these technologies in our everyday life. And when this infrastructure will be completely realized, and it will become even more important and essential for our society, the next step that is already happening is a further integration into rather big areas, infrastructural areas, for instance that of telecommunications and that of Earth observation. And in the future we should expect really the development of many sophisticated and very advanced applications that are integrating telecommunication, Earth observation, positioning, navigation and timing. And this concludes my presentation. I thank you very much for your attention.